Okay, just carry on from that. Again, pretty straightforward here. There are, you don't even have to remember these equations because they're in the Nat5 handbook, but there's two things to think about, okay? If you're looking at pyramids and cones, so if we're looking at these kind of shapes, pyramids and cones, okay, we've got a surface area, we've got a shape, and then it comes to a point, okay? That is similar to our um, volumes before. So before we would have said volume is equal to the base area times the height. Okay. So if we were looking at our kind of cuboid, something like that, we'd say, well, what's the base area, and then multiply by the height. Okay. Now, if we take a shape that's got the same base area as that, but instead of being dragged up, instead of being dragged to form this kind of shape, what if it was to be, to come to a point, okay, where all these lines come to a point, okay? So that's our new kind of concept, okay? So instead of just dragging the shape up to make it a block, okay, we're gonna draw lines from the base shape up to the kind of center, okay? Now that is always going to give us 1/3 of the block kind of area, okay? Simple as that, okay? So when we're looking at this kind of shape, we know the area is going to be the length times the breadth. Okay, that's fine. But when we're looking at cones, it's going to be pi r squared times h because the pi r squareds are circle. Okay, so don't look at this and think, lots of algebra, it's a bit complicated. It's not. Okay, we're just breaking it down. We've just got our base area, times it by the height, and it's 1/3 of that because of the nature of what we're doing. We're not doing this. We're not dragging the square up to form another square, or dragging the circle up to form a kind of Pringles tube. And now we're kind of drawing a point in the middle, and we're drawing lines to that. Okay, so that would be like our cone. Okay, so imagine like that. So that area in there, that volume, sorry, is 1/3 of the full thing. Okay, dead straightforward. For a sphere, again, you're given this, so pi r cubed times by h. Everyone forgets it's cubed, not squared, okay? So when you're thinking in volumes, you should be thinking in cubes. And obviously here, that's two lengths if you think about it, r and r, two lengths, times by h, so you get three lengths, and that's why that works. Oh, sorry, there's no h in that, so it's pi. And this is pi r cubed, sorry, whoops. And that's your three lengths, okay? R for the sphere, and r cubed in h is like three lengths. So you should always have three lengths for cubed, and that's why the units are always in millimeters cubed or centimeters cubed. Okay, but you're given these equations, okay, so don't stress too much, okay? You will be given these, okay? So, yeah, same as before, taking an area, times it by a height, except when it's this kind of shape, like a cone or a pyramid, we put 1/3 in front of it. Simple, okay? And the sphere, just accept that as your equation and make sure you get the radius right. Don't use the diameter is the big no-no for that. Okay, but you're given that equation, dead straightforward. Okay, so I just got to talk through a few of these then. Okay, so question one, say I was to do that. Well, what's my base? So what's your equation? Volume is going to be equal to 1/3 times my area times my height. Now, what's the area? Well, the area in this case, I just told you, it's 12. It's kind of complicated shape. That's hexagon. So yeah, just 1/3 times the area they've given you, which is 12, times the height they've given you, which is 11. Okay, so that's going to be 4 times 11, which is 44. And that's in meters cubed, okay? So what I've done, we don't need to round that, obviously, but what I've done there is a very standard way of doing it. I've written my equation down, I've substituted in, I've had a quick check, I've done my number, and I've made sure I've got the right units. That actually is a 3, even though it looks like a 2. Okay, that's what you should do the whole way through. For the next one, what's the base? 6 times 4, 24. Divide it by 3, it's going to be 8. Times it by the height is 5, it's going to be 40 centimeters cubed. Straightforward. This one we talked about before. These little lines, they mean that they're all the same length. So what's the area of the base here? 7 times 7, 49. Okay, so 1/3 times 49 times 9. Straightforward. This one is the base of a triangle. What's the base of a triangle? A half times the base times the height. Half times 20 times 14. What's the height of this entire thing? 15. Divide by 3. Okay, nice and straightforward. It's just always that equation there for substituting. What's the base area? What's our height? Okay, so it's area of a triangle, a square, a rectangle, a hexagon. Okay, simple. So 12, 24, 49, half base 140 would be your base areas. Times them by a third, times them by their heights. Easy. The cones, again, just the exact same equation, except now we're using pi r squared for the area. What's the area of this? Pi times 6 squared. What's the height? 14 divided by 3 because it's a cone. Okay, over here, pi r squared. What's the radius? It's going to be 2 this time. Pi times 2 squared, that's the area of a circle, times by 11, all divided by 3. Okay, nice and easy. The only one that was quite interesting was this last one I thought, which we kind of went over before, but it was a wee bit tricky. Okay, so this time we're saying, well, the volume is equal to 1/3 pi r squared h. Okay, now it says to find the height. Okay, so there's two ways of doing it. Let's try two or three. The first thing to do, I think, is to think on it as v is equal to pi r squared h divided by 3. Okay, when you do a third times something, you're dividing it by 3. Okay, I think that's an easier way to look at the equation when we're doing this. Okay, when we're doing rearranging. Okay, now when we're doing the rearranging, you do the opposite function to move something to the other side. So right now we want to solve for h, so we want to move everything else over. Okay, so how do I move 3 over? So right now I'm dividing by 3, so how do I move it over? Well, I times by 3. Okay, so 3 volume is pi r squared h. Okay, how do I move over pi and r squared? Well, I'm doing pi times r squared times h, so they're timesing, so I want to divide. Okay, so to move them over, we're going to divide. So 3v divided by pi divided by r squared. Okay, so I've moved both of those down. They were timesing, now they're dividing. Okay, so it's 3v divided by pi divided by r squared. Okay, so I know they're timesing each other, but they're dividing v. That was the point. Okay, so that's one way to look at it, and then you would substitute everything in. You could do that. You could also substitute in first. Okay, so say you think, oh, I hate rearranging, don't want to do it. Well, you could start life off by just saying, well, what do I know about this equation? Well, I know the volume. Okay, I know the volume is 310. Yeah, I know my equation. I know a third times pi times r squared. What's r? 5 squared times the height. I know that. Okay, and then you can actually just work that out. Okay, so you just get a calculator out. Okay, and that's going to give me 310 is equal to 26, I'll just call it 0.2, okay, times h, okay. So now you're thinking, that's an easier equation, isn't it? So 26 times what gives me 310? Well, you should know it's roughly going to be about 12 or something, isn't it? Because times by 10 would give me 260. So if that was an easy number, if that equation was, 10 is equal to, 5 times h, you'd be saying, well, no, h is 2. But I said, well, how have you done that? How do you know that? Well, what you've actually done is divided. Okay, you've moved this over. Before you would have said, well, 10 divided by 5 is 2. So if we say 310 divided by 26.2, that's going to give us h. Okay, we've moved over the 26.2. It's times in, move over, we divide. Simple. Okay, and if you actually think about what you're doing there, what we're doing is we're saying, right, we need to keep this equation in balance. So to get rid of the 26.2, I'm going to divide both sides by 26.2. Okay, that keeps it in balance. Okay, if I divide this side by 2, divide that side by 2, etc. But what this does here is it cancels that out. If I do 26.2 divided by 26.2, cancels out and becomes 1. And that's why it appears over here as the opposite function. Okay, so you could do that as well. That's what I thought was quite interesting. So this question here is building on your knowledge of rearranging as well as your new knowledge of volumes. Okay, so two ways to tackle that. You could have done it algebraically to begin with, then substitute it in. I think a safer way is just to actually do what you know. Just substitute all your numbers in, and then you've only got one move at the end. But I think it's worth thinking about are worth being able to know and do this method as well. Okay,